Hello, this is John from caveofprogramming.com. In this video we're going to take a look at the any class in Kotlin, and we're going to take a look at the hashcode equals and toString methods of any. As an example, let's create a class up here. So I'll create a class which I'll just call cat. Let's give it one property called name of type string, and I'll put the brackets in here because we are going to be using them. Let's create a couple of cats. So I'll create a cat1, that's a type cat, and I'll set it equal to a cat. And let's call this cat Bob. And I'm going to duplicate that, which I think is Command D on my Mac. And we'll have a cat2. Let's give that a different name called Sue. Now let's try to print these. So I'm going to print cat1, and we'll duplicate that, and we'll print cat2 as well. If we run this, you can see that what gets printed out, we've looked at it before, but it's pretty incomprehensible. We get the class name and its hash code. Now we can make objects of classes print out in a more readable way using the toString method. But let's take one step back first. So even though you can't see it, every class in Kotlin ultimately actually extends or inherits from a class called any. So any is at the top of every class hierarchy, and the any class has three methods which you can override. It has a method called toString, a method called hashcode, and a method called equals. And that's what we're going to be looking at here. If we override the toString method of any, that can then supply a string that will be printed out whenever we try to convert the object to a string. So when we print these cats, they are in effect getting cast to strings, and what then appears is determined by the toString method. And at the moment cat has the default toString method. The easiest way to change this is not to type out a toString method yourself, which is a bit error prone, but to right click and go to generate in IntelliJ IDEA. And other IDEs like Eclipse have a similar facility, and we can choose to generate a toString method here. So this dialog lets me choose which fields of the cat class will be included in the generated toString method. But we can easily change that ourselves anyway. And here we've only got one property that we can include. So let's click OK. And you can see it overrides this toString method that exists in the any class, which cat actually derives from. And it's just returning this string here. But we can return something else if we want. Let's change that to I am $name, a cat. So now if we run this program, we can see it says I am Bob a cat, I am Sue a cat. In fact, we could even do something like this. Let's say val text is a string, and that's equal to some cat colon $cat1, and let's print that and see what we get back. So if I run this, you can see again we've tried to use the cat object as a string, and it's given us the results of the toString method. We can also call the toString method directly if we want. We can say, for example, cat2.toString, and that's obviously just going to return whatever the toString method returns. So if I run this, again it's printing, in this case, I am Sue a cat. So that's toString, but there are a couple of other methods that are also very useful. Firstly, by way of an important aside, let's take a look at the idea of equality in general, and in particular referential equality and structural equality. So if I do print line cat1 and a triple equals cat2, what this does is it tells me if the two references refer to the same object, which in this case they don't. So if I run this, you can see that we get false coming out down there. So the referential equality operator, this triple equals sign, just tells me if the two references refer to the same thing or not. To prove that it does actually work, let's say val cat3 equals cat1, and then instead of doing this, let's compare cat1 to cat3, and then we'll see that we get true. So there's true, because these two references refer to the exact same thing. However, there's another idea about what it means for two objects to be equal, and that refers to structural equality, or you could call it semantic equality. And there we're asking, do these two objects have the same contents? or are they equal in some other important sense that you can define? So for that we use the double equals operator. Let's do println cat1 equals equals cat2. In this case we're just using a double equal sign. And if we run this, we find that no, they are not equal as expected. But suppose cat2 has the same name as cat1. Let's make them both Bob, and let's run that. In this case we're still getting false, but you could well consider these two cats to be the same cat, or at least if not the same cat, then they are equal to each other. They've got the same name, cat has no other properties, so ideally we will probably want equals equals to return true here, to say that yes, these two cats are equivalent to each other, even though they don't refer to the same object. So we can make this work as we might want by overriding the equals method. Let's click in here, create some space maybe, and go to generate. So I'm right clicking, going to generate, and I'm going to select equals and hashcode. And it asks me what properties I want to be included in equals, because we might have multiple properties and we might want to consider two cats to be equal if they have, for example, the same name. They might also have an age, and maybe we don't care about age. It's just completely up to us what the definition of structural equality actually is. Let's click next. And again, it's asking me what properties to be included in the generated hashcode method. Let's click create. So our equals method is here. And we know enough Kotlin now, if you've been following this series, to understand how this is working. So the equals method receives a reference to another object, which can be null, so we've got that question mark there. It's going to return Boolean, true or false, to indicate equality or inequality. And we can see that if the this reference of this object refers to the same object as the other object passed in, we're going to return true. If both references involved in a comparison refer to the exact same object, then they have to be equal by any reasonable definition. Then we're checking the Java class of this object and comparing it to the Java class of the other, taking into account that other may possibly be null. So we use the safe call operator here. If they don't have the same Java class, in other words, if the two classes being compared aren't of the same type, then we may as well return false because they can't really meaningfully be equal. Then we've got this puzzling line here. But as we've seen, this unsafe cast operator as will throw an exception if this cannot be cast to this. So this is just a way of getting equals to throw an exception if these classes are not compatible with each other. Other has to be either cat or a subclass of cat. And finally, we're checking whichever properties we want to check to do the comparison. In this case, we're just checking that name is equal to other.name. So they have to have the same name property. In that case, we will be returning true. Otherwise, we'll be returning false. Now we should expect that this equality comparison will actually work because the equals equals operator actually invokes behind the scenes the equals method. And if you're used to Java, this is quite different to Java. In Java, this would compare two references and you'd have to invoke equals explicitly. In Kotlin, equals equals actually invokes the equals method. And if you want to compare two references, you use the referential equality operator, triple equals, instead. Let's run this and see what it does. So we can now see that cat1 and cat2 are indeed equal. As for the hashcode method, we have touched on this before. It generates a code which isn't necessarily unique for each object, although most of the time it is. And this is used as a quick way of the initial phase of checking for equality. For example, when you add objects to a set. So best practice in general is that if you implement equals, also implement hashcode. And you don't have to implement either of these yourself really. You can just automatically generate it, so that's pretty simple. So here's all the code we've got today. This stuff's pretty straightforward, so if you just practice it a little bit, I think you'll get the hang of it pretty quickly. So until next time, happy coding.